Okay, so today we're getting the slope from a table. So I'm just going to do a few examples so that you guys know how to do these problems. Okay, so we have a table and we're just trying to figure out how much it's changing. So how much our y values are changing and how much our x values are changing. So how do we go from 3 to 4? We add 1. How do we go from -4 to 1? We add 5. Then we need to write our slope. A slope is a fraction. It's like a unit rate, but a unit rate has to be over 1. Our slopes can be over any sorts of numbers. So we put the change in y on top of the change of x, and that makes our slope 1/5. Now, if you can reduce, you need to reduce. If you can't reduce, then that's totally fine. It doesn't matter which of the ordered pairs you choose to use. So, for example, we could look at this next set. From 5 to 7, we would add 2, and from 6 to 16, we add 10. So the slope for these two ordered pairs would actually be 2 over 10, but again, you have to reduce. So when you reduce, 2 goes into 2 once, and 2 goes into 10 5. So we get the same slope. So on your tables, it doesn't matter which two ordered pairs you use. As long as you reduce, you end up with the correct slope. Now this slope is an increasing slope, just like on our water tanks. So we're going to be gaining water. So we want to think about the picture of our slope. Okay. Next. Oh, sorry. There we are. Okay. So how do we go from 4 to 2? We subtract 2. How do we go from -3 to 1? We are going to be adding 2. So our slope for this table is the change in y over the change of x, which is -2 over 2. Again, we have to reduce. 2 goes into -2, -1 time, and 2 goes into 2, 1. Sorry, I was going to put 2. That's silly. You can write it as -1 over 1, or you could just write it as -1. Either answer is correct. Again, we're looking at our slopes. Since it is a negative slope, it's going to be decreasing, so we are losing water, and the picture of this would look like this line. Again, we'll do more with this in the next days to come, but we're just trying to get an idea of what things are going to look like before we get there. All right, now, in this table, to go from 30 to 24, we are going to subtract 6. And to go from -3 to -4, we're going to subtract 1. So our slope is our change in y over our change in x, so that's -6 over -1. Here, we can't reduce our numbers, but we can reduce our signs. So a negative over a negative is actually a positive. So our slope is 6 over 1 or just 6. Either of these two answers are fantastic, but they need to be without the two negatives on it in order for it to be correct. Now these are both positive slopes, so the graph of this slope would be increasing, our water tanks filling with water. Okay. Now, these are the new ones, and we also need to change this to a -1. Sorry about that, it got lost and forgotten. Okay, to start, to go from 2 to 3, we are going to add 1, and to go from -1 to -1, then we add 0. So our slope for this problem is going to be 1 over 0. Now, if you put 1 divided by 0 in a calculator, you have to turn it on. Oh, dang it, and I turned it off again. Sorry, 1 divided by 0, it's an error. You can't actually divide by 0, so it doesn't work. But this is important to remember, so we're going to just write down error, and we'll come back to that. Okay, next, we're going to look at this table. To go from -8 to -8, we add 0. To go from -3 to -1, we are going to add 2. So our slope is our change in y over our change in x, which is 0 over 2. Now, this problem, when you put in 0 divided by 2 in the calculator, right where the glare is, then you get 0. So the slope on this, for this table, is 0. So we're going to talk about what these two pictures look like, because these are new, and we haven't talked about those before. Whereas the increasing and the negative, and the decreasing, we talked about with the water towers. Okay, so let's just draw a cute little picture really fast, and it doesn't have to be fancy. Representing our table. So if we were to graph these ordered pairs, the first table, we would go -1, 2, -1, 3, -1, 4.5. So you get the idea. It's going to be a nice vertical line. On this table, we're going to go -3, -8, -1, -8, -0, -8, 1, -8. So again, you get the idea. That's what this graph is going to look like. Okay, so back to the water towers. And if you're not quite sure what those are, we talked about these water tanks last week. We compared lines and linear equations, and we talked about the top tank and the bottom tank and what it looks like. So on the top tank, this is a water tank tower that we were talking about. The water is leaving in the top tank and going into the bottom tank. So over time, the top tank is losing water, so it has a negative slope or a negative unit rate. The bottom tank is gaining water over time, so it has a positive rate or a positive slope because it's gaining. So losing, negative, gaining, positive. All right, so that's why we talked about the losing and the gaining on these two slopes. For here, these are slightly different because they don't lose or gain. They're just kind of odd. So over time, this tank is like if you sat out the tank of water and you didn't do anything with it, and then you looked at it over a few intervals of time or periods of time, it stays the same. So this is not increasing, it's not decreasing, it's a slope of 0. So we call this a no slope. Okay, this slope here, this would be like if you had a water tank and then randomly a UFO came. Yes, very exciting, a UFO. It came and it sucked up all the water. So this UFO got all the water. Okay, we call this line undefined. And the reason that I said UFO is to help you remember this U in undefined. Another way that you can think about it is when the 0 is underneath, it is an undefined slope. So this slope is undefined. Also to note here that we can graph these equations. These are lines, and we've graphed them, but this slope of this line is undefined, and the slope of this line it's not there. It doesn't have a slope, so it's called a no slope. So these are the 4 different slopes that we have. We have decreasing, increasing, decreasing has a negative slope, increasing is a positive, undefined with a 0 underneath, and then a no slope when our slope equals 0. Okay. So we're going to do one more example together. We are going to look at these tables. So these tables, I'm going to do number 7. On page 22, these tables were part of your assignment. Okay.
Graphs.
What did I say? Tables? Oh, my bad. These are graphs. Okay, so this graph was part of the assignment as well. So notice on here, I don't have a table, and I've been using the tables to get the slope because that was the goal for today. So what we're going to do is we're going to have to create a little table. So what we do is we look at the line, and we're going to find an ordered pair that we could put on here. Now, if I picked this ordered pair off to the side, I'd be picking -5 and then 2.4. And subtracting decimal numbers, it's not the most fun thing, and we can avoid it. So we're not going to use this ordered pair. So we're looking at our line, where our line touches the corner of boxes, so here, here, or here. These are the ordered pairs we're going to write down. Now, I have three spots where my line touches the corner of boxes, and that will give us nice whole numbers for our ordered pairs. Just pick 2 of them. It doesn't matter which 2. So this ordered pair is at -3, 3, and this ordered pair is at 0, 4. Then we do exactly what we've done before. How do we go from 3 to 4? We add 1. How do we go from -3 to 0? We add 3. My slope for this is going to be my change of y over my change of x, which is 1 over 3. It's positive. I already have a positive graph, so I don't need to graph it again.